All right, let's talk about the calibration system itself. We're going to go into a little detail about your gas source and your regulator. We'll also touch on filtering and tubing. However, before we do that, we're going to take a look at two systems. One system for calibration of flow controllers, the other is for calibrating flow meters. So in the flow calibration system, the path is pretty straightforward. In this diagram, we show the gas coming from a bottle into a regulator. Next, we go through a filter. That's optional, but a good thing to have. And then into the flow reference, or flow standard. And finally, we use the flow controller under test itself to regulate the flow moving through the system. Now, in some cases, there may be upstream and downstream pressure requirements for the flow controller. And that will require it to be moved upstream of the flow reference. Or let's say you're using a piston prover flow reference. We're going to cover that later. You will need that type of reference to vent to atmosphere. So again, the flow controller would need to be moved upstream. Now, another thing you can do in these cases is to set the valve open using valve override and calibrate the unit under test as a flow meter using another flow controller or manual valve to control the flow through the system. So let's look at the setup for calibrating a flow meter. In this case, in addition to the flow meter under test and the flow reference, you will also need a mass flow controller to change the flow rate during the test. The same comments regarding pressures apply again. Now, ideally, we'd like to have the flow reference upstream of the unit under test. That way, any contamination that might be coming from the unit under test does not contaminate the flow reference. Of course, if you're looking for a flow controller to use in this type of flow meter calibration system, we'd like you to consider the Teledyne 300 view. It has a local touchscreen display as well as analog and digital I/O, so it's very flexible for calibration systems. It has a very good accuracy specification, which is 0.5% of reading plus 0.2% of full scale. So if you're calibrating a less accurate instrument, this unit can also serve as a flow reference, and we'll get into some of those later on. All right, next we're going to talk about some of the different gas source options, and for many applications you can simply get a gas bottle using nitrogen or air. Aside from being heavy, they're generally easy to connect and handle. Now, some labs I've seen have used liquid nitrogen. In this case, you may want to use a heat exchanger to ensure that the gas is near room temperature before being introduced into the calibration system. If your lab has house air supply, you may be able to use that. Ideally, your house air is going to be oil-free or at least filtered and also well-regulated for pressure. I've also shown here a compressor at the bottom of the slide, and you can get these with big ballast tanks. Same comments as before. You don't want oil in your system to get into your test units or your flow standards. So now let's talk a little bit about regulators. And this can often be an overlooked important component of the system. If the regulator is not sized correctly for your system, you can get instability, which in turn is going to show itself in the data. So how do we get the right regulator? Well, when you talk to your supplier, they're going to need to know the following. They're going to want to know the flow rate, maximum, the inlet and outlet pressures, minimum and maximum, and they're also going to ask your gas type, and they're going to want to know whether you want stainless, aluminum, or brass. I also want to say a quick word about filters. If you're going to invest in nice flow reference standards, then you should also consider placing a filter in line to protect your standard. Keep in mind that the filter will have some pressure drop across it with increasing flow, so make sure your system can handle the flow rates, even with the filter. Another consideration is tubing. As expected, you want to think about the flow rates you'll be using. For large systems, make sure your piping's large enough for your highest flow rate. Also, at high flows, try to maintain a straight run of pipe. You'll see different guidelines on this. We always like to see a straight run upstream that's at least 5 times the diameter of the inlet of the unit under test or the flow reference. This will also help give well-behaved flow that in turn will give better calibration data. If you're testing flow controllers at high pressures, of course, make sure your piping is rated correctly for those high pressures. Now, if you're working with low flows, then urethane tubing is very easy to work with. If you're handling really low flows, say like 10 SCCM and less, then you'll want to select small ID tubing and keep the length short so you'll have small volumes. Otherwise, you're going to have long lag time between the flow readings. If you're doing a very small flow, you may want to use a bypass around the regulator. So just as a general comment about piping and tubing, you want to match your tubing size to your flow rates. Now, when you're assembling the system, make sure everything is leak tight. The soap bubble, you see this brand name Snoop, right, can be used to quickly find gross leaks. Now, to detect small leaks, you can also use pressure decay technique, and some flow references will offer this mode in their systems. And you can see here, a leak will corrupt the data run because although the flow is detected by the flow reference shown there, the full flow never quite makes it to the flow meter under test.